Okay, so now let's talk about the derivative of the inverse cosine function. So d dx of inverse cosine of x actually equals negative 1 divided by the square root of 1 minus x squared. So it's the same thing as the inverse sine function, but we just got a minus sign in front of it now, right? So doing this, we could actually do it just like we did the inverse sine function, but then we have to worry about all those little technical details, and that's just kind of a pain. But luckily, there's an easier way to do this one now that we've already done the inverse sine function. So first of all, let's start with y equals inverse cosine of x. All right, we'll start with that. So this means x equals cosine of y. All right, but cosine of y, that's the same thing as sine of pi over 2 minus y. Okay, so that's a trig identity there. That's one of the complementary angle things here. Okay, cosine of y is sine of pi over 2 minus y. So this means that x equals sine of pi over 2 minus y. Okay, so now if we take an inverse sine of both sides, then that means inverse sine of x equals pi over 2 minus y. Alright, so now we have that. So in other words, let's go ahead and add y to both sides. So then we have y plus inverse sine of x equals pi over 2. Alright, now let's subtract inverse sine of x from both sides. So let's just go ahead and erase this, and we'll do that there. So then we're going to have y equals pi over 2 minus inverse sine of x. Okay? So notice here we have two different things that y equals. So we started with this, right? This is how we defined y up here with this. Y equals inverse cosine of x. And now we just found this out just from using this trig identity here and then doing a little bit of algebra. We have these two things here. So y equals this guy and y equals this guy. So that means these two guys have to equal each other. That's some good old-fashioned transitive property there. So what we just figured out is that cosine inverse of x equals pi over 2 minus sine inverse of x. Okay, again, the reason is that this guy equals y, and this guy also equals y, so they have to equal each other. So now we can just take a derivative of both sides, and what's going to happen when we do that? Well, we're going to get d dx of cos inverse of x equals d dx of pi over 2 minus inverse sine of x. So that's going to be, so here we can differentiate term by term, right? But pi over 2 is just a constant, so what we really have is a derivative of this is just 0, and then we have minus the derivative of this. So minus d dx inverse sine of x minus that. And we know from the last video that this is just going to be equal to minus sign still out front here, and then we know from the last video that that's just 1 over the square roots of 1 minus x squared. And that's where this formula comes from here. So again, we could have done it like we did inverse sine of x in the last video, but that's just going to be a kind of a headache. So it's a little bit easier to use this trig identity here. That's the key, is to remember this here. So that's the proof for the formula, for the derivative formula for the inverse cosine function.